In this video, we're going to take a look at examples number 7 and 8. However, I'm not going to start by doing these problems for you. I'm going to ask that you try to go ahead and see if you can attempt these problems on your own to see how well you are actually understanding the ideas that we've been discussing thus far. Now, I would say don't worry about evaluating the integrals, but rather just set them up to see if you can get the setup correct at the onset. Now, to do this, I would recommend that you pause the video here to try to work through these questions, and then when you unpause, you should be able to see me working through the solutions. All right, so you can see here that I've sketched out my original region over on the side, and I've also sketched out here my region, my mirror image, and the line that I'm rotating around, which is y equals 2. Now, if I again am going to start to play the game of connect the dots with my different points, I can see that I'm definitely going to create the shape of washers as I begin to connect some of these points. So notice here, as I go around, I create a big circle, but at the same time, there is this inner circle that I have to be careful to sketch. So I have this in here. And it's always really hard to draw this carefully, but now I can go ahead and I can kind of imagine shading in the spot that I know to be solid. I always highly recommend doing a little bit of shading with washers just because it can become a lot easier to see what it is that you're looking at. So you can see here, this is the washer type shape that I have. And as I move my washer further to the left, that circle gets bigger, or the empty circle gets bigger. As I push it further to the right, that circle gets a bit smaller. So I'm going to go ahead then and try to think about how exactly would I imagine my radii on here. But like we said in the past couple videos, it's important to always draw your radius going back to your original region, which in this case is down below. So my big R here is going to be going all the way down to there. There's my big R. And my little r is going to be going all the way to the edge of the inner circle right there. So there's my big R and my little r. Hopefully then you can start to see how I would set up the volume here. First, I can recognize this is definitely going to be dealing with washers. And so I have this basic formula structure. Big circle minus area of small circle. I'll give it some thickness, and since these stack horizontally, I'll use dx. I can even see already my bounds should be 0 to 1, since I'm going to be moving across this particular region, which starts at 0 and goes over to 1. Now to find my big radius in red, notice I need to find a y-coordinate on top and a y-coordinate on bottom. The y-coordinate on top is always 2, but the y-coordinate on bottom is determined by my quadratic function. So here I'm going to have 2 minus x squared. To find my green radius, the short one, I'm going to have 2 minus my inner function there, which is going to actually go all the way down to that line. I might not have fully sketched out. There we go. I think my green part goes all the way down to there. But it should go all the way to that line, just like up here it went all the way to the line. And so I should end up with 2 minus x. So this would be a setup to tackle example number 7. And how exactly I would go ahead and do that. If you haven't yet finished working through example number 8, again, I'd ask you to pause the video. When you unpause, you'll see me working through the solution. For example number 8, you can see again, I've sketched out my starting region, which is exactly the same as it was in example 7, but now I'm rotating it around the line x is equal to -1. So I can see here that I have my original region and its mirror image duplicate, and now I can go ahead and I can start to play connect the dots. So again, I'm going to have a curve that goes out like this, comes back across like that. And I can also see that down here, if I go ahead and I select another value and grab some points that are all mirror images, I'm going to have connecting these outer points to these outer points. I can see again this washer-like shape beginning to form. Again, it's always helpful in my mind to go ahead and shade in your washers so that way you can actually see very clearly the region that you're working with, especially in this case where things can get a little bit jammed. like over here on my back edge, I maybe didn't draw one of my dashed lines high enough, and so it can be a little bit tricky to see the shape that I'm working with. It seems like I have something kind of like this shape, right? There's my washer. Now I'll notice immediately that this is going to be a washer or a bunch of washers that are going to be stacking vertically on one another. And therefore, I know that even though I'm going to have that same basic washer setup of big circle minus a small circle, this is going to have to be a dy question. So that means immediately I'm going to want to know how low to how high can these washers go. Well, very clearly here, my intersection point on these curves is 1, 1. That's pretty obvious to see. And so low side of my region is 1, and low side is 0, and the high side is still 1. So I'm going to go from y coordinate 0 up to y coordinate 1 at the very, very top. However, to measure the radii of these circles here, again, I have to draw back to the original region. And of course, since these are horizontal lines, I'm going to need to have x coordinates in order to measure how long each of these individual pieces are. So remember that the x coordinate on my left side is already -1, so that's pretty easy. The x coordinate on my other side, though, is kind of a mystery, right? And it's always going to be changing. So I can see that my red x's are going to be determined by my function y equals x squared. But again, I'd like to go ahead and take that function and convert it into an x equals, which of course here is plus or minus, not plus or minus y, but plus or minus square root of y. Since I'm only dealing with positive x's at this point, I know this is just x is equal to root y. So the square root of y is equivalent to that x. That lets me know that my big radius could be given by red x minus -1 or square root y minus -1. I'll write that here just like this. Of course, if you wanted to write that as a +1, you're more than welcome to, but I want to still understand, or at least highlight here, that we are just doing a simple subtraction. Notice I can do the exact same thing with my green function, although this one is super easy to solve for x, because you just flip it around. So here I can see that if I want to measure the length of my green radius, it's x minus -1, but that green x is the same as y, and so I'm going to end up with y minus -1. Keep in mind, if this is a dy integral, everything has to be in terms of y. If you wrote anything in here with x's, that's not correct. You'd have to have everything in terms of y's. So hopefully you were able to get these specific integrals that we calculated here. If not, you can try to go back, rewatch these videos, make sure that you understand how to get there. And again, please do try to go ahead and calculate these integrals. And you can check the answers for those integrations up in the notes in Blackboard.